Go ahead.
Chakrabarti sir, just 1 minute. I just want to know that like these two windows are open on my screen. Like one I'm going to webinar viewer and another one is this. So I can close them. There is no problem. No?
Don't close it, sir. You only focus on your PPT. Everything is fine. Don't close anything. Shohita, please start.
Okay, sure, sir. Good morning, respected Chancellor, sir, Vice Chancellor, sir, Dean, sir, Provost, sir, HOD, sir, and our beloved audience. I believe every one of you are in good health and taking precautionary measures to protect yourself from the COVID-19 pandemic. Today, Institute of Electronics and Telecommunication Engineers, IETE Students Forum, and Indian Society of Lighting Engineers, ISLE Students Chapter, jointly present a technical webinar on satellite image processing. These societies are continuously aiming, organizing the technical programs, special lectures, workshops, seminar symposia, and exhibitions for the welfare of students to provide a common platform of students for proper exchange of ideas in technical issues of interest. These societies have also organized quiz, technical paper contest, essay competitions, technical visits to industries, and had also conducted intercollegiate functions and had facilitated technical visits, project works, contact with industries and academic institutions to uplift the team spirit and self-reliance among student members. So now, I would like to request our Honorable Chancellor, Sir, Professor Dr. Satyajit Chakrabarti, to enlighten us with his words and also to encourage the society members.
Good morning to all of you. It is certainly a wonderful occasion today, Saturday morning, to be able to hear the famous Dr. Vikas Mittal. He is an expert in satellite image processing. You know, our country is, one of the 5 countries in the world to have very strong capabilities in space research and satellite manufacturing. There is immense opportunities now in the area of space research and satellite technologies. You know, already, there are 2 big private players, which is, Blue Origin from Amazon and from SpaceX. They are already putting thousands of satellites to space, and they are coming up with new applications such as terrestrial internet that today you receive via lease line. Very soon it can all be able to done online through the satellite. And also the image processing for military applications, mapping applications. There are, I think, thousands and perhaps millions of applications. So there will be a huge growth for those who take up satellite technologies and satellite research and also image processing. So I request Dr. Vikas Mittal to give his talk on the area of satellite image processing. It's going to be very, very informative. I request all the members to take notes and ask questions in the chat box, in the question box. Okay, thank you.
So Shohita, are you going to say something?
Sir, yes.
A brief bio about Dr. Vikas, please.
Sure. Today, thank you very much, sir. I'm sure your words will always motivate us to organize such technical activities in the near future. And today, we're obliged to have Professor Dr. Vikas Mittal with us, Associate Professor and former Head of the Electronics and Communication Engineering Department in NIT Kurukshetra. He has completed his graduation in Electronics and Communication Engineering from NIT Kurukshetra and his post-graduation and doctorate also from NIT Kurukshetra. He became the HOD of the same department where once he had been the student. Recently, under his able leadership, the ECE department of NIT Kurukshetra was awarded NBA accreditation for 6 years for its BTech ECE program. A strong believer in the industry-academia collaborations, and as an alumnus of NIT Kurukshetra, he has envisaged and implemented many projects at various levels which are of great practical significance. Recently, he has submitted reports on sponsored research project worth 22 lakhs, which was funded by the DRDO Government of India on developing data fusion algorithms. His outright teaching experience is about 27 years. He has authored about 60 research papers in international and national journals and conferences. The region of his expertise is signal and image processing, along with current focus on sensor and renewable energy. Presently, he is working in the areas of satellite image processing, SAR imaging, signal processing and control system, wavelets, sensor fusion, biomedical signal processing, renewable energy, cyber physical systems, and so many more. Now I would request you to, sir, please illuminate us with today's topic, satellite image processing. Over to you, sir.
Thank you, Sohita, that you have given a very nice information about me, a brief about me, and I am thankful to you and your Pro-Vice Chancellor and Chiradeep for giving me an opportunity to interact with you people. I think when I was approached for this lecture, I was told that we are going to have a talk on satellite image processing. And when I inquired about that, what should be the scope of my talk, then I was told that I have to like cover from the basics, like giving some idea about that how to start with satellite image processing and then go on to the latest trends and the future directions that one can take in satellite image processing domain. And this is a very interesting field to begin with. The reason being that uh, it is not that since I belong to this field, that's why I'm saying that this is very interesting. The reason is that this is a direct application, applied field. Because as an engineer, when you want to do something with your hand and you see the things working in front of you, then you feel very, very good about it. And you feel that, okay, something I have done. So sense of accomplishment is there. So this is that kind of field where you get a, you can say, the feeling of the things happening in front of you. And the expertise or the principles from the other domains like signal processing, image processing, electronics, then other things, they have to be put together. They have to be put together so as to realize a satellite image processing system. So if I just start with, like, so we are all familiar with satellite because India in the last few years have come up as a good, you can say, space power in terms of various launches and providing launch vehicles for various satellites of different countries. And I think we have a record as a country that we were able to launch like 104 satellites in a single launch vehicle. So that kind of so we are all familiar as Indians that what about the satellite. But here when we talk about satellite image processing, then it is we are taking satellite as a sensor because presently in the present era, what is happening is that we are a data-driven society, and if you look around, that everywhere we have got data, we are overwhelmed with the data. For example, if we look at our mobiles, you see a lot of SMS, lots of WhatsApp messages, videos. So you're all surrounded by the data. So a lot of observation sensors are there. We are talking about 5G. We are talking about IoTs. We are talking about that we have to do some kind of automation in offices and homes. So everywhere we have to make use of sensors, right? Wireless sensor networks. This is another common term that we come across nowadays very frequently. So satellite is basically a, if I just refer to it, it will be a launch it will be on board. You can call it like just as an aeroplane, right? And the sensor on board the satellite will be called as a passenger, right, or an instrument that is there on board satellite to be used for observations, right? It could be observations for anything. Normally, it is the planet Earth that we are to inquire about. So, what is the first advantage? The advantage is that we have got a big, you can say, kind of a sensor that is observing from the space. So there goes a saying like "Upar wala sab dekh raha hai," right? That kind of thing is there. So this is onboard sensor on board a satellite. So it is basically providing you the observations and again some kind of data, right? So these observations, when that is represented pictorially, right, that is known as an image. So as an audience, I think I am not aware of that. What kind of, I have been told that the audience is some of the faculty members and some of the students also. So you must be aware of that. What is the difference between an image and a picture, right? I normally ask this question to the students when I teach them image processing. So conventional image processing, not the satellite image processing. And there the students normally say get confused between the to tell the difference between picture and a image. Now, if I, so here since we are not interacting, so I may not be able to pose the question, but definitely I will like to tell you the difference between the two. The image is where the object is not recognizable in the picture, and it is simply the pictorial representation of the data. For example, X-ray will not be called as a picture, it will always be called as a image, right? Similarly, ultrasound will always be called an image, ultrasound image. It will not be called as ultrasound picture. The picture will always refer to where the object is recognizable in the image. For example, like we have got our own pictures, like clicked by the cameras or the mobile phones. So that is where the object, like it is an individual, is recognizable. Some object is there, so that is known as a picture. So observations provided by the sensor on board satellite, when represented pictorially, that is called an image, right? So that's why we coined the term that this is satellite image. And definitely, if you want to process the data out of it, trying to get certain conclusions, so that domain will be called as satellite image processing. So I think now we are clear that what kind of inputs we have and what kind of things we are expecting to achieve out of it. So as I told you that I think this is visible to you, all of you. If somebody confirms, I am audible also.
Yes, sir, you're audible and the slides are visible. Everything is fine.
Okay, very good. So as I told you that the satellites have got different applications. Right? Nowadays, we are relying it more and more on satellite observation data and the satellite services. The reason being that we are operating on the global scale, right? Even the Google is also planning to launch the satellite-based internet services to the world, and this kind of thing, whenever the scope is bigger, means like we have got a bigger scope and we want to operate on the planet level, right? Then definitely we have to have some observatory or observations far apart in the space. So different kind of applications, most of the applications you are all aware, because we have been using it knowingly or unknowingly in one way or the other way, right? But just to you can say complete the things, I have just outlined few of the applications, right? And the first artificial satellite Sputnik was launched in 1957, and from there on, these different applications were developed. And the most common application of the satellite nowadays is DTS, direct to home services, right? Where we call it as a dish TV, right? Where you dish TV, not exactly dish TV, but it is a dish antenna on the rooftop, and you have got a set-top box, and then you watch different channels, entertainment channels. So this is the most common example of you can say satellite applications. Everybody is touched upon by this, and now you can see a lot of dish you can say on the rooftops because they have become very cheap and affordable. Then telephones, right? Telephony, you must have heard about that there are the satellite phones being used by the terrorists, right, for doing communicating from the areas where the areas are unreachable. So even if there is no network, still the satellite telephones are working. And for the normal persons, the in-flight phone communication in remote areas, they are provided by the satellite telephony. Then navigation is another important application that is touching, I think, almost all the people nowadays. If I remember it correctly, when I used to visit Delhi, say like 15, 20 years back, then we used to lost, right, in different parts, and the you can say the different streets. And then we used to keep on asking, "Bhai, yahan jana hai, so how to reach there?" This kind of things were happening. Nowadays, we are pretty good with our, you can say, navigation facility available in Google Maps, and to just click this, and now they are inbuilt in the vehicles also. I think you will all agree that this kind of application, navigation, is being touching for all the lives, right, of different people. The next application is business and finance, right? Now you know that we are like you must have seen the Amazon, right? This is uh, inventory management, right? Different locations, inventory management, they can use satellite-based services, right? We are having instant credit card authorizations. You can use your credit cards across the world, right? Irrespective of seamless connectivity, basically, right? For all the business and finances. And after demonetization, then this assumes more significance because we have to rely on more and more online services. Then weather monitoring is another application that is purely dependent upon satellites. Recently, you have seen two cyclones, one on the west coast and one on the east coast. So there you must have seen that a lot of pictures were available on the internet where it was shown that how the cyclone is approaching the coastal areas of Gujarat and Odisha respectively. And they were showing the pictures. So all these things were visible, you can say, were possible because of the backbone provided by the satellites. Right. Then we have got early warning system. Again, there were a lot of news on the television where the people were talking about that this is approaching. So you have to, like, they get the coastal areas vacated and things like that. So hurricanes, volcanic eruptions, burning gas, oil fields, all these things are there. And I have quoted an example of recent forest fires in Uttarakhand and Himachal Pradesh. Again, of course, this is few years back, right? So all these things can be monitoring is possible because of satellites. Then climate and environmental monitoring. Again, climate change is a very important topic nowadays. Everybody is talking about it, and the countries around the world, they are putting their resources just to contain the dramatic climate change that is happening around. And to observe the climate change, again, of course, at the global level, we have to take the help of satellites. For example, change in sea levels, change in glacier size, right? Then determining long-term patterns of rainfall, vegetation cover, emissions of greenhouse gases. All these things, they are made possible with the help of satellites. Then safety, right? Safety is another thing. And if you remember that recently there was a barrage of ONGC that got damaged because of the cyclone, and the oil spills, etc., were monitored by the satellite. Right? How these, what is the extent of spill, extent of damage to the sea vegetation and the sea life. So that kind of things are possible with the help of satellites. And emergency rescue operations in remote areas can be done with the help of this. For example, in 2013, when there were flash floods in Kedarnath, right, the extent of damage, etc., can be easily determined with the help of satellite image processing. Otherwise, it would not be possible in the short span of time. Then land stewardship is another important application, right, where the resources, natural resources are being monitored and assessed, that how much a country or a region has got these kind of this, then how much the topsoil has eroded, then monitor large scale infrastructure. If you remember that recently the satellite images were released, they were available on the internet and they were shown on the news channel also, showing the Chinese build-up near the that in the Ladakh area, right, the near the line of actual control, right, that kind of things were happening, and these images helped in monitoring the large scale infrastructure build-up, right? So imaging of the entire land mass on the earth can be done with the help of. So this is known as typically the land use and land cover classification. This classification with the help of satellite. Then development can be very well facilitated because the more you have got the information as an entity, right, over the wide areas, spread over the wide areas, then you can easily plan, right? And I belong to I am connected to the remote sensing lab at IIT Roorkee also because I did my doctorate from there. So there the lab we have developed a product called Agriculture Information System that is based on satellite, and that is operating at the district and the taluka level, and this is providing a lot of meaningful inputs to the administration who can take decisions just to take care of the things. The space science, of course, it is a most common type of applications which is beyond you can say common user, but this is giving us good understanding of the universe, how this is operating and things like that. Just wait. Sorry, there was a little bit disturbance, right? So if I talk about types of satellites, then everybody is aware that different kind of satellites I have already told you. So, but if you count their number, am I audible? Hello.
Hello, sir.
I am
Audible, sir. You're audible
audible.
and the slides are visible.
Okay, okay, very good, very good. Actually, you just lost track now. Basically, I don't know that whether everybody is listening or not. So I just keep on speaking. That kind of thing.
No, sir. We are audible, sir.
Anyway, so 20 nations have launched over 80 Earth observation satellites, because we are talking about here the satellites which are of providing these kind of services. Otherwise, there are communication satellites, there are weather dedicated satellites also, but normally which are more concerned with the satellite image processing, right? They are 80 in number. They are civilian space programs basically. For instance, we have got, I have mentioned few satellite names: GOI-1, QuickBird, Heroes A, Iconos, IRS, Pulsar is there, which I have forgotten to mention over here. They are some of the high resolution satellites. High resolution means that I think everybody is aware of the resolution in an image, because now we are talking about 2 megapixel camera in the mobile phones, 4 megapixels, 6 megapixels. So pixels is basically the smallest unit in which you divide the whole image, right? So the higher the resolution, the more you zoom, you get more clarity of the image, right? It does not distort. Salt and pepper effect is not visible. So resolution few centimeters to 3 to 4 meters means on the earth surface, if you draw the squares, a pixel measuring 2 centimeter to by centimeter to 3 to 4 meter, 3 by 3 or 4 by 4 meters, that is termed in the satellite image processing as a high resolution satellite image. And the image, I think I have made itself very clear that it is nothing but the pictorial representation of the data. Then there are certain medium resolution satellites also, Rapid Eye and Landsat 8, right, the 5 meter and beyond till 56 meters, because beyond that it is not very you can say usable, because you are not able to distinguish the objects beyond that. So when this is 5 meter, by 5 meter pixel, and beyond that, then is known as the medium resolution. So this is basically we divide the satellite on the basis of resolution it is providing, the resolution of the data. And second, you can say the criteria of the, dividing or categorizing, classifying the satellites is based on the fact that in which part of the electromagnetic spectrum they are operating. That is very important, right? You know that this is, I have shown the electromagnetic spectrum. This I have taken from the net somewhere, right? I have just pasted it on this slide. And you just see that this ultraviolet, infrared, and satellite observations, they normally use they operate in the visible, infrared, and microwave portions of the spectrum. Now here I will like to elaborate more because you know that how the frequency matters when we are talking about some sensor. This is very important. There's simple physics behind this, and you must have read it in +2 classes also, and later on, that the wavelength, the size of the signal is nothing but the wavelength, right? So the wavelength size should be comparable to the dimensions, physical dimensions of the objects, right? If that has to be detected or that has to be recognized. So if the wavelength is very large, right, and the physical size of the object is very small, then that large wavelength will overlap the object and the object is not distinguishable. Clear? So that is the case with the smaller wavelength also. If the wavelength is very small, it is just like a runner who is running on the field and having a step size very small, then he will not be able to jump the hurdles, right? If it is a hurdle race. And if it is too big, then it will, you can say, maybe crossing the hurdles, 2 hurdles at a single time in a single step. So that will defeat the purpose of the hurdle. So this is the same kind of thing. So every comparable dimensions of the signal should be there. So depending upon the object that is being observed on the surface of the earth, because we're talking about the satellite imaging and this is a global scale, so we'll call it as an object on the earth, that we have to choose the frequencies or wavelength, because it is just like um, reciprocal. And if you see that higher earlier we used to have low frequency communications for entertainment, and that's why the antenna size were bigger. Now for DTH the frequency size is very high. That's why the physical dimensions of the dish TV antenna is very small. So they have to be a direct relationship between the object size, between the physical dimensions, and the frequency or the wavelength of the signal involved. So visible is just like an optical camera, right, that you are using it in mobile phones or otherwise. So it is just a click of the picture, click of the earth surface. And infrared is something which does not require much light, even if in this light, so this kind of a thermal, towards the thermal sense. And microwave is something which is coming up as a radar. Basically we use microwave in radars, and where we see that uh, the radar is in the microwave portions, and it does not need any light, and even it pierces the clouds, right? But still uh, you can say in some time. So microwave is basically used where we want to have a robust observations, right? Robust observations we want instead of uh, this thing, visible and infrared, because if clouds are there, visible will not operate. And if you can say uh, that there is no difference in the temperature of the objects, then infrared will not operate, right? So there have got a limitations. So now there is another reason for using these 3 bands from the electromagnetic spectrum, because sun gives most of its energy in visible and infrared region, right? So when we use the naturally occurring energy, then because most of the, you can say, the satellites, they operate from sun, so sensors are also being designed which operate from the sunlight, getting the energy from there. So naturally occurring energy if we use, then the visible, infrared, they are the most visible, brightest portions in the, that means largest amount of intensity is involved in these bands. For example, Landsat recorded 4 separate bands simultaneously, red, green, and 2 near infrared bands. So this is known as multispectral satellites. And if we have got like 7 or 8 bands, then we have got hyperspectral bands also. So accordingly, we call multispectral satellites data, and we call hyperspectral data, we called optical data, we called microwave data, and things like that, right? Now here I want to tell you one more story that nowadays uh, the optical and this infrared, they have come up to a saturation stage, and almost this kind of satellite data have been processed and have been you can say interpreted in different manners by different authors. A lot of literature is available on them, right? But the microwave is an upcoming field. It provides you two advantages. One is that it does not depend upon the light, because it is just operating as a radar. You know that microwave energy is impinged. When it gets reflected, that reflection is collected, and you get the you can say microwave backscatter, right? That is, in technical terms, it is known as backscatter. So, and we are trying to, like the researchers are trying to work on microwave data, satellite data, just to have the visual appearance as if it is an optical image, visible range, or infrared image, right? So because we are more habitual of having a visible optical data, we are habitual of seeing the pictures and all that. So that is the reason that there is a lot of scope, still a lot of scope to work on microwave portions of the microwave satellite data. Now, if we talk about and there is a particular name for microwave data that is known as, uh, I will come on this later on because the next slides contain these kind of things. Now, if I talk about satellite imaging, as I told you, it's nothing but the pictorial representation of the satellite observation data. And it is the most advanced application in the satellite services. And through complex signal processing, this pictorial representation of the data is achieved. Now, somebody may ask question like, when I initiated into this field, then I was also perplexed with the same question, confused with the same question, that when Google Maps is available, that is also satellite data. Google Earth is available where the satellite data is visible. Then why we are going for another kind of satellite image processing? Why we are looking for other products? The reason is that if you are aware, the Google Maps is nothing but it is simply the stacking of different images at different resolutions. And as you just zoom in, what happens is that the different layers are accessed with different details. So, and it has to be updated time and again. It's not a real-time data, right? So static information is there, which is not useful for analysis and processing. So if you want to have a real-time system where some kind of, for example, DTH, if you talk about, some signal is coming from the satellite and you cannot process it, that means you cannot view the channel. You cannot wait for like the things to appear 10 minutes after when it has happened already 10 minutes before. So that is known as static information. Now, another important thing is when we talk about image processing and data driven, basically, when I mentioned data driven society, basically nowadays everybody has to aware of how to do pre-processing, how to extract the data. Pre-processing, extraction of the data is basically pre-processing, part of the pre-processing. So three things have to be, you can say, taken care of. The first one is pre-processing. Second one is features extraction. Features, you understand the characteristic of the data, which can you can say on the basis of which you can distinguish the identify the trends in the data or distinguish the patterns in the data and things like that. So feature extraction is very, very important, right? So there is a feature extraction, then feature redundancy, then feature selection, right? Feature reduction. All these things are they belong to the domain of feature extraction. So this is very important, and the better the features, the better will be the interpretation or classification. So in the case of satellite image processing, two kind of features are there. One is the data features, that what are the features involved in the observation, satellite observations, and the second one is the target features, like the objects to be observed. Then resolution and antenna size, this is very important factor. If you look at this resolution, I have already talked about, right? But if you want to increase the resolution, then you have to have a large antenna size, right? This is again physics or electronics that you can refer to somewhere. But if you want to go into the space on board a satellite, then you cannot afford to realize the large antennas, because larger the antenna, the more will be the drag and more will be the other design issues, and it will be a stability issues. So it will not be possible that you are getting out of this thing. So this is a difficult proposition. So what happens is that we can, the researchers thought of having the you can say the manipulation of the signals involved in the uh, sensors, just to have high resolutions even with a small and manageable antenna size. And here comes the integration of the two facts. That is, one is known as microwave data, right? And then is smaller size of antennas. If we combine the two things, then this is known as synthetic aperture radar. So presently, we should concentrate more on the microwave satellite data. And second is using a lower size of the antennas, smaller size of the antennas. That's why these two things are, both of them are available in a product that is known as synthetic aperture radar, or more popularly as SAR. Okay, so this is one thing. So we have concluded this thing. We have reached this thing. Second thing is, if we have got a typical satellite imaging system, what are the things that we should, what are the expectations? The expectations is that it should provide the observations 24/7 by 365, round the clock, round the year, right? It should be autonomous. That means irrespective of the kind of targets, irrespective of the kind of portion of the electromagnetic spectrum, and irrespective of the size of you can say the data, it should give me the conclusions which for which it has been designed. So that means it should be autonomous. For example, when you talk about autonomous, then the different kind of robots are there now around us nowadays. And if we want them to be autonomous, means they should initiate their action on their own without any prompt. I think I made myself clear. Then autonomous means that there should be minimum or no human intervention involved. Right? That means humans are not required to be part of the system. Then it should contain active information. That means the real-time data should be there, which we can use it for different applications. And it should provide me the accurate results. So these are the, I think, 5 or 6 characteristics should be there for any satellite imaging system, irrespective of the type of the satellite, irrespective of the type of the data, in which part it is operating, what kind of objects it is observing, and things like that. Now, how I have arranged my PPT here, that I have talked about, I have given you, set up the landscape, that what is the satellite image processing domain is all about, right? Then of course the other details are there, which are the satellites. I also could have put the tables, detailed tables that are available on the internet, but that does not serve the purpose. The only thing I want to share is that if you want to have a satellite data, then commercially it is very costly, but for academic research it is available from the agencies which have launched the satellites with a particular sensor, and based on the sensor we are putting the names of that data also, right? And for example, the Iconocos data, right, that is the name of that particular sensor data. So every different agencies in India and abroad, they are launching their satellite with different sensors, and they are sharing their data, right, of particular date, a period of the year, right, for the academic institutions for further research, and that data is of the order of few lakhs, right, depending upon the size of the region in which you are, for which you are looking for the data. So when I was organizing my contents for this lecture, I found that this field is very wide. Lot of variations are available, and if you just put satellite image processing on internet, you will find that a lot of things are available. So the people get confused. So as an example, what I thought of is that I should take an application, that is land cover classification, out of several applications, right? But anybody who is interested, they can just look for more applications and more satellite imaging into that particular application. So this will help me in illustrating better, right, that how the concepts and things that I just discussed can be utilized for a particular applications and what kind of inputs and outputs are available, right? So that because I have been working into this area, so I am able to show some results on this. Okay. So land cover classification is an important, you can say, application. And if you look at the importance of this, that you know that lot of vegetation is ending up, and we are getting more and more sand and more buildings coming up. So that kind of land cover can be identified on a global scale with the help of satellites, and you can compare the satellite image of taken, say, example in February with March, then in April, then in May, so as to compare that how much vegetation has reduced, how much different crop patterns are there. So things are like this. And in our country, like India, we are an agrarian society, so this is very, very important for all of us. Now, another important aspect is natural resources are increasingly becoming scarce. So definitely we have to manage them efficiently. And some remote terrains are there which are not accessible physically, so they can help in this way that we can find out. For example, there is one study of uh, water content identification or classification on the surface of moon, right? You just can look in internet and you will find Chandrayaan 1 and Chandrayaan 2 data has been used to identify the water, existence of water on the surface of the moon, right? So that is uncharted and remote terrains application, right? So that is nothing but a land cover classification. You are identifying water on the surface of some planet, right? Then this I've already told you. Now, again, the same thing, the satellite-based observations of land cover, cost-effective and versatile because of that single sensor can observe large areas. And the aim is to minimize the errors. Means that if we identify land cover classification based on satellite data, right, on the ground, that similar condition should happen. It should not happen that from the image we are getting that, okay, this much square kilometer area is vegetation, and on the ground we are finding it few meters. That should not happen. So error should be as minimum as possible, right? In the two things, that is, one is the analysis on the satellite data, and another one is that what is the fact existing on the surface of Earth. And this is still a challenging problem, right? Even though much of the progress and the work has been done, but still it is going on. I will talk about the factors which will come into play and to relate them to the generalized domain of satellite image processing later on. So as you see that accuracy of land cover classification and in general for any application, right? It depends, as I talked about, type of the sensor. It could be an active sensor or a passive sensor. Active sensor is where the source of energy is inbuilt, and the passive sensor is where the source of energy is from somewhere else. And of course, it is sun in this case. So few of the sensors I have already written, like LIDAR. You must have heard about radar, is very famous among us because we travel by air and we see that it is solely the capability of the radar that an airplane can fly. Then sonar is another thing which is operating below the sea water, and this is very, very useful for underwater applications in the sea, like for example for submarines and all that. Then passive is MODIS. MODIS is another sensor. This is the name of the sensors, right? Aster is another sensor. So we can say Aster data, Aster satellite data, then MODIS satellite data, LIDAR data. So all these things you will find in the literature when you just search Google. When you Google these terms, then Landsat data. Again, this is a land satellite. So basically they are the name of the sensors, right? Based on which we can say that this is the kind of the data. Then frequency optical hyperspectral microwave. This again I have talked about. And the second factor is features. What kind of features you are relying on for analysis. And then intermediate processing, feature reduction, selection, these kind of things. And the last is the classification approach, whether you are using the supervised or unsupervised. The name itself explains. Supervised means that you are a party to that, means you provide some kind of input data so as to get the output data. In case of unsupervised, there is no need of any input data. You simply give the image and it will give you the results. So as I told you, the desirable characteristic would be microwave based active sensor. This again I have explained. Then minimalistic and simplistic features. Again, this is very, very important. You should have a minimum number of features because that will make speed up the system. And unsupervised classification is preferable because there is no need of any prior information. Because if you talk about like as I mentioned that to want to detect water, presence of water on the surface of moon, then there is no prior information available with us. So in that case, unsupervised, and it is a, you can say, step forward and autonomous system. That is very important. If a system has to be autonomous, then it has to rely on unsupervised classification. Otherwise, this is not possible. Now, if it, so let's you can say concise our discussion now from now on to the microwaves because this is the current trend, right? And I have mentioned the name of the SAR also. This is nothing but that we are getting the high resolution data with the minimum antenna aperture size. So I'm just putting some terms in front of you, and if you are interested, you want to get initiated into this field, or you are working and you're getting some problem, you can always contact me. I have mentioned my email ID, or you can have it from your UEM, or it's available on my institute website also, electronics department. So this SAR is important thing, right? And if you Google it, you will find a lot of information about this thing, right? And you know that when we talk about microwave, we have got different bands. If you LSC, QK, right? These are the bands which are dividing from 1 gigahertz to uh, approximately 20 gigahertz. That is a kind of range in which we have got different bands. And accordingly, we have got satellite data like L band, S band, C band. Again, this kind of literature is available on the internet if you just go ahead. Second thing is very important part. Like earlier, we used to have a SAR, synthetic aperture radar, simple mono SAR or the multi-SAR. But there the thing was that if you have got one sensor, you have got two sensors, then you have got different, you can say, two sets of data, observation data, you can have an interpretation, right? But more data is not always good, right? More information is good, but more data is not always good because if the data is more, then it creates a problem like big data problems. And you know that the complete industry is operating on that domain, big data. So another variation was another development in the SAR domain was polarimetry. Polarimetry means you know that electromagnetic waves they are polarized, and the polarization is simply known by the direction orientation of the electric field vector, right? So that is known as polarization, and we have got you can say when the incident microwave energy is interacting with the object which is being observed, right? They change in the polarization. So this enhances the information, which in turn increases the accuracy or more better interpretation from the data. So this kind of system is known as polarimetric SAR, and if we talk it in short, this is known as POLSAR. Okay, the polarimetric SAR. This I have mentioned in red. So again, this is very important domain where you can see a lot of things happening around, and they have happened. So if I just give a very quick, you can say, because I think I have got a limitation of time also, and we can keep on speaking. This is an endless topic and such a wide topic. So I will just go hurriedly from here and just to keep on introducing and telling you the recent trends, what we should do further. So possible channels in pulsar data is HH, where the transmission is horizontal, receiving is horizontal, VV, HV, VH, and this is a bilateral system, so HV and VH, they are same, right? So basically, essentially, there are three channel information. So more the information, better is the interpretation. Then what is the basic of SAR sensing? You know that microwave energy that impinges on an object gets scattered, and that scattered is you can say collected by the sensor again and to give the observation data. So there is a particular way, and the whole group of persons, they are still working on the modeling the scattering mechanisms. As you see from the thing that if flat surface is there, scattering is like this is known as scattering mechanism. And if the rough surface is there, then this is the kind of scattering you observe. Scattering means just the reflection pattern of the incident microwave energy. And volume scattering is from the trees like this. So these are the kind of scattering. Basically, 4 or 5 scattering mechanisms are available. Helical scattering is also available nowadays. But people are, you can say, keep on modeling, but still it is not perfect. Because had it been perfect, then we can identify directly by looking at the scattering mechanism. The moment we have got microwave sensor, we could identify the scattering mechanism and we can identify the object. But they are not unique. Multiple objects, they are, you can say, offering different same kind of scattering mechanisms, or you can say different scattering mechanisms are given by the same object at different points of time. So this is very confusing, right? So the reflection back is not a bounce off. For example, if you look at any image, satellite image, I will show you some images, right, with the example. That's why I'm just, you can say, keeping away, but doing a little hurry now onwards. So if the bounce off is less, means less scatter is there, then the surface would, the data would be less in value, and backscatter would be less, and it will appear dark in the image, right? And if the bounce off is more, the brightest will appear and intermediate intensities would be there in between. And definitely when we are talking about the pictorial representation of the data, it will always to be in the gray shades, right? So this is again the kind of scattering mechanism which you see that when the incident wave is there, upon interaction, this scattering polarization changes. So they're introducing additional information about the target. Then the kind of different scattering mechanisms are there. The more one type of scattering is there, right, the better you can say that there are more chances that this object belongs to that particular category. Okay, and the surface roughness and dielectric properties of the media, they are determining the kind of scattering, and which in turn is a function of SAR frequency, polarization, and incidence angle. So different polarization channels contain different information, and we have to use them judiciously to get the better interpretation. Then feature extractions, again, this is kind of spatial features, transform features. Again, these are theoretical aspects. You can have a look at it. Different kind of features are there based on the data. Texture is a very important thing in satellite image processing. Then when we talk about the pulsar features, right? So I just basically show you this slide, right, where this provide me the polarimetry SAR features background, that based on one category of the feature is based on the original data and it's transformed. Another is on polarimetric data decomposition, and third one is the other features, right, which are not falling into the first two categories. The other features could be texture or the color, and the middle column, this middle branch, right, this has been researched upon very actively in the literature by different persons, and especially Professor Yamaguchi from Japan, right? He has worked on this thing, HA alpha decomposition. But again, this has reached a certain, you can say, saturation level, right? Beyond that, we are not able to have better accuracy. Then the basic is scattering matrix, coherent covariance matrix, backscattering intensity. So something has been done based on scattering matrix, some coherent or covariance matrices. But again, the backscattering intensity, that has not been much utilized as of now. So you can work on texture, color, and things like that. I have taken an example study area also. This is the region of Roorkee and this is the region of Kurukshetra. So I have shown this, right, where I am located, Haryana, Kurukshetra, and this is Uttarakhand, where the Roorkee is located. And I have taken the example data of ALOS, Advanced Land Observing Satellite. This is an L-band synthetic aperture radar, popularly known as PULSAR. So this appears as PULSAR in the literature. And these are the Japanese agencies, JAXA and JAROS, who have who launched this thing. So these are simple characteristics giving you the resolutions, polarization, incidence angles, swath width, and these things like that. So I will not go into details. So these are the details of the data that has been used. So this is the kind of raw data you will get. Some files which are not recognized by the computer system. So you have to use specialized softwares for the purpose. For example, one is the some free tools are available, some commercial tools are available. NV is one example, environment for visualization of images. Then Geomatica is there, ArcGIS GIS is there. So these kind of things are there, right? Next is this is the Pulsar data pre-processing. Again, this is depending upon the kind of sensor. So here, since this is a specialized, you can say this is not a general procedure. This is only applicable to the pulsar data. And that is what is the biggest problem in this field, because every sensor, every satellite data, it has got different kind of pre-processing technique, right? So this has to be experimentally determined or to be told by the designer of the sensor, right? So that how you have to extract the data in the image form from the raw data. Raw data is basically not recognizable. So these are the kind of images that you have got, right? And georeference is another term that is used, georeferencing. What it means is that you have to, because it's an image is nothing but a matrix, right? Some containing some data. So you have to arrange them in such a manner that every point on this belongs to the particular lat and long on the surface of the earth. Okay. So this is very, very important. If it is not, then you will not be able to have the exact interpretation, because then it will not correspond to the actual surface of Earth surface. So this is different polarizations, different kind of data, and if you just look at it, you will find that that intensities are different in all the polarizations, HH, VV, then HV, and these are the Kurukshetra region, same sensor data, pulsar sensor, right? Again, three polarizations. So this is the kind of data that you can extract. Put them georeference means that you have got lat long mention on the outer periphery of the image. You can color code the different polarization, right? And you can show them in a single image. That's why it is shown HH, HV, VV. So blue color is by VV channel data, HV is green, and HH is this thing. So this is the Roorkee region, right? Where you can have the different land classes which you know from the physical ground survey, right? Like U is urban and W is water, that we know. And this is the Roorkee canal which is flowing from in between the city. And both sides it is the city, right, with a bright area. So this is known as false color composite, because the different channels are shown by different colors, arbitrarily chosen, red, green, and blue, right? So this is Kurukshetra region data. So again, nothing is you can say clear from the image. You cannot make out, because I am aware of the region. That's why I know that what kind of things are happening, occurring in this kind of image. But as a audience, you may not be knowing. So, but as a general person, you are not aware what lies inside this an image. So these are the examples again. backscattering coefficient, right? So different land features could be there. Gray shades, as I've told you, more the backscatter, brighter is the spot on the surface. Otherwise, it will be darker. You see that there are certain dark spots and there are certain bright spots. Bright spots means more backscatter, and the dark spots means least backscatter, and gray means in between extent of backscatter. So this is being collected and provided us as an observation data. So if I have chosen six classes: water, urban, wetland, bare soil, short vegetation, tall vegetation, just to classify this. And if you see that these are the ground sample points, because you have to have some actual ground truth data. Whenever you want to classify something from the satellite images, you have to have a ground truth data. So ground sample points have to be there, which you know confirmly that okay, this type of land cover is available in this particular region. So here the blue is shown by water, red is showing urban, wetland, and this is the ground truth data that we had collected. This may be collected with the help of Google Earth also and physically also by survey. Then these are the backscattering coefficients plots of different classes. So you see that they are lying in the different range of the backscatter. That means you are able to distinguish them based on the backscatter energy. This is what is the information conveyed in this diagram. Because more it is mutually exclusive, better is the identification. Then kind of supervised classifiers used in satellite image processing: parallelepiped, minimum distance, Mahana Lobby's distance, maximum likelihood, and unsupervised. So these are normally built-in classifiers available in the commercial softwares like NV, right, and Pulsar. So here I have taken an example of the backscatter coefficients like sigma HH, sigma HV, and sigma VV, and use their different ratios and different things to identify the different land covers. And if you just look at this, I just show you the image. So this is the ROIs, region of interest, where you have selected in a particular region and showing different areas. And you see that these are the kind of parameters used by the to measure the accuracy of the classification. One is the producer accuracy, user accuracy, overall accuracy, and there is one more thing which is known as kappa coefficient, right? So kappa coefficient is basically level of confidence. Producer accuracy is basically capability of the classifier used, and user accuracy is based reflecting on the user accuracy of selecting the land covers on the ground truth samples, and overall accuracy is the general accuracy. So these are just to you can say complete the discussion. I have just mentioned it, the technical terms, and if you see some results, the maximum likelihood classification is there, and see that data is there, and you are using ground truth points, and you classify the image. So you see that there is a water is shown by the blue, right? Urban is shown by the red, and somewhat is similarity, but again it is not 100%. And you will be amazed to see that different classifiers like Wizard supervised classifier, they have got a different, and this these colors are nothing but the color coding, and the color uh, bar is shown here, color coding bar is shown here, that blue means water. So depending upon the classifier, you have got different accuracies and different kind of images. Same image convert to this, and if you just look at the value, which is you can say benchmark in the Wishart supervised classifier, this has got only 65% of the accuracy, overall accuracy for different classes. And if you do unsupervised classification, k-means classification, this is Wishart unsupervised classification. If you compare them, this comes out to be 57.14, and you see that the backscatter coefficient, they are also giving very good comparable accuracies, like of the order of 60%. But anything that gives us 60% does not mean anything, right? You will not like to work. Even we are not going for the vaccination, which is assuring us of 60 to 70% of effectiveness against coronavirus, right? I think everybody is aware of that. So 60% accuracy is not practical. And the way that is being used to increase the accuracy is with the same kind of satellite data is by using fusion. This is another concept that is upcoming nowadays. A lot of data fusion activities are going on in the research community. And if you happen to see on the net, you will find that the things are happening around. So image fusion or data fusion, they are interchangeable terms that are being, you can say, utilized in the literature. So here what we have done is that we have tried to use different fusion, right, techniques, and on the similar data, same data, and then we try to see that whether the fusion is increasing the accuracy or not. So if I show that there is one SFA based fusion technique that is used in SAR image processing, right? Then there is a PCA, principal component based fusion. This is another technique. Then this is an expectation maximization algorithm. This is one of my papers have come up in advanced space uh, journal. It's an SCI journal, which you can just find it on internet by googling expectation maximum algorithm for pulsar data for land cover classification, right? So again, this is a theory. I should not go into this, how to model using, how to apply the EM algorithm. I will show to you the results basically. So when you fuse the image using SFA, so what we proposed is to fuse two channels only. Means HH is there, HV is there, VH is there, and VV is there. I told you that two cross polarization channels means HV or VH, they are similar. So effectively we have got three channels, HH, VV, and HV. So if we fuse any of the permutations and combination of the channels, we found that the accuracy increased, right? So this is the kind of images that you have seen for different fusion techniques, and you see that it comes out to be approximately 65%, right, as compared to other fusion techniques reported in the literature. And this 65% is again less. As I told you, that if there is a reliability, even though it is more than 57 or 60, 5 to 6% increase, but here we can make out a conclusion that fusion, if we apply fusion in some way on the satellite data, then we can expect more accuracy. I think it is fine with everybody. So, and if we, you can say, find out the accuracy of the fuse channel, three fuse channels, HHHV, HHVV, and HVVV, combine them together, still we have got a higher one, around 70%, right? So this is a kind of observation that we can see, and we can make a comparison before and after the. So you see that it is unfused image, then this is the fused image. So you see that there is a direct increase of around 20 to 15 to 20% as compared to the unfused data. So basically all these things, they are telling us even 35% increase is there. You see UF1 30% and F1 is giving me 65%, right? So to an extent of 30 to 40% increase just by applying the fusion without doing anything extra. Data is same, processing is same, extraction is same, features are same. You are just doing the, you can say, fusion techniques on the data. So this has been compared with another one, Wishart unsupervised classification. We are looking at accuracy of 57.14%. So this is very way ahead of almost 13%, right, by just applying the fusion technique. Am I audible? All these things are visible to you, people?
These are all visible, sir. We are enjoying.
Okay. Okay, very good. So there are certain problems with that. The Wishart distribution algorithm has been shown here just because of the fact that this is a benchmark algorithm as reported in the literature. And you see that all the things are, you can say, there is a problem with the initialization. The lower classification accuracy means if the initialization is different, the accuracy is different. So it depends on the chance, right? Whether you have started correctly or not. Second thing is clusters. Clusters means unsupervised grouping of the data, right? Similar data. So that may not be corresponding to any physical land cover. Means there is nothing corresponding physical thing on the surface of the earth. So these are the kind of domain, right, kind of data. So input data is nothing but a raw data, then you extract it, do pre-processing, extract the features, do the classifier. But again, everywhere you can have different kind of things. You can have different features, you can have different classifiers, you can have different pre-processing has to be specific to a particular sensor. So I have tried to demonstrate by taking the help of some physical example, practical example of one kind of sensor data, that is pulsar data, which is L band 1 to 2 gigahertz, right? And try to show you that what kind of things we expect at the output side. Okay, so these kind of images and these kind of tables should be generated automatically if it is an autonomous system. Now, after showing this one example just to demonstrate the things, now I am going to discuss with you what are the future directions, right? In what direction we should move further. So as I told you that different domains have got different things. Means you can have changes in the features, you can have changes in the uh, feature selection, reduction, and classifier. So we can have unlimited possibilities. And since it is based on data, right? So data, all the data-driven technology, all the data-related technologies can be applied. Like data mining is there, pattern recognition is there, right? Then we can have neural networks, deep neural networks, right? Artificial intelligence, machine learning. All these domains, they can be applied directly on data just to have better interpretation. As I told you, the accuracy is the major concern. So the highest accuracy that I have been able to locate now at present on the this thing is around 87 to 90%, but still it is less. We have to have the accuracy of uh, around 95% plus so as to make it a practical system, right? Clear? So like in the GPS also navigation, if Google says that, okay, I have got an accuracy of this much, just to instill confidence in the user that this kind of thing. So trends are autonomous systems are being explored based on pattern recognition. By recognize pattern recognition technique is there using machine learning, using pattern recognition technique, using artificial intelligence. This is one thing. Then a lot of data is available. As I've told you, satellites are providing a lot of data. So high performance computing is required to solve the big data problem, right? So HPC clusters, the basically high performance computing is being explored. Techniques are explored. Then there is a word called INSAR. Now, as I told you earlier, the SAR was modified to include polarimetric information, converting it into a pulsar. Now, another variation is there that it is known as interferometry SAR. So that is known as INSAR. Okay. And recently, we are using polarimetric plus interferometric. So that is known as POL-INSAR. Okay. So these are the different variations of the SAR data. So these are the ways in which we are modifying the sensor, and the purpose is same, to get more and more information, not to get more and more data, but to get more and more information in the same amount of data. So that is but still the data is very large, so high performance computing techniques is a sought after domain nowadays. Then again, as we have been I have shown you the example of few algorithms like autonomous system, like PDF based. We are working on PDF based recognition system, PDF modeling of the data patterns existing in the data, right? But still they have not been reported. That's why I'm not producing it here, right? But that comes under the category of autonomous system based on pattern recognition. Okay, so I have just mentioned its scope, but not shown any results over here. Then, as we are trying to develop new algorithms for multipolarization SAR, the data, similarly, it has to be multipolarization in SAR data, which I just talked about, that polarimetric and interferometric information in the same SAR data qualifies for new investigations and explorations. Then you can use machine learning methods for land use, land change. Change analysis is very important in this, because you want to see that how a particular region has changed over a period of time. So time series analysis is very important, right? All those techniques can be applied. Basically, the satellites keeps on revolving in the polar orbit on different orbits around the surface of the Earth. So it passes on to the same area after a particular amount of days, right? For example, Pulsar just does it every 43rd day. So this is the way that you are getting the repetitive data, and this is qualifies for time series analysis, because same region, different times, the same observations. So you are just getting the time series for that, and you can use apply all these things. So in SAR analysis for hidden signals from the sets of Earth observation big data, then study and characterization of forested areas, and applications are unlimited, right? You can work on anything. Then different multiple sets of site data collected by different SAR instruments. There may be more than one SAR sensor, right? Like pulsar and this thing. Then we are using nowadays fusion of optical data with microwave data, fusion of optical data with infrared data, fusion of optical, infrared, and microwave data. So all these things, they are basically being explored, and a lot of literature is available on different kind of fusion techniques. Then geophysical investigation, again for natural and human induced disasters. Then current and forthcoming Earth observation missions can be utilized for this purpose, geophysical investigations. Earth atmosphere study can be there, Earth oceans study can be there based on SAR technologies. Characterization of coastal areas, delta river regions, right? So all these things can be thought of. Now aerial surveys are also possible. And nowadays there is one more activity is going on, that we are using drones with the microwave sensors. And this is happening in our lab at IIT Roorkee also, not in NIT Kurukshetra. So there, the drone is there equipped with different side of sensors, and they are used to monitor the, you can say, the breakage in the railway lines for different applications, and that data is supplemented or fused with the satellite data to get more interpretation to increase its scope. So that kind of thing is there. Okay, so I think I have introduced all of you well to the domain of satellite image processing, and given you a demonstration also. So with this, I end up with my presentation, and now I invite any queries or any comments or any interactions that you want to have with me.
So there are few questions in the question box. So maybe I will read those out, though I believe one or two of those questions have been already answered, because the question was posted way back in 11:45 at 11:45 a.m. So after that, the question was answered, but still, because he's a student asking this question, so I will keep it in front of you. Roshan Kumar, final year of EC student, saying he is doing a project on satellite image processing.
Can I also see the questions? Okay, chat.
Yes, sir. Yes, sir. I will do that.
Where is that?
I'm just assigning it to you, sir.
Okay, okay.
Sir, if you can kindly look at it, I have assigned it to you. You'll be getting something called questions in your in the app. So the question says that, sir, I'm final year EC student and he is doing a project on satellite image processing. How can I get high resolution satellite images? Is there any repository where I can access free satellite images for further processing? I think you gave a part of this answer in your question, in your presentation.
Yes, yes.
But sir, if you want to add.
Yes, this is to be acquired by the institution, because as an individual you may not be able to spend like 2 lakhs of rupees, maybe 1.5 lakhs or 2 lakhs for a particular region. So you have to tie up with some lab or some institution, or you may be asking to your professor in your institution, where they can go for some academic purchase of this kind of data, but they are definitely available at a reduced price, concessional prices for the academic research purpose.
Okay, so Professor Chirodip, are you there? I will request you to immediately look into this so that we can purchase a part of this data at least for the students to continue with their project work.
Yes,
So the
yes,
second question is from Professor Sandeep Das, asking again a similar question. So like he is saying that he has been trying to see the pattern of river Ganga, how it changes its course, new landform, etc. And he has used a limited data set. So he is wanting some suggestion where we can get data set freely
This
available.
question is not visible.
Okay, I'm
This
again assigning. Sorry, sir. Again, I did not assign it to you. I will just assign it.
okay. So every time you have to assign a question to me.
No. I will assign it as a whole now.
Yes,
I
yes.
will assign it as a whole now.
So that I can just have a scroll and look at it.
Yes. You can kindly look, sir. I'm assigning. I have assigned. I have assigned.
But this is
Can you see
okay.
the
You can
question,
read
sir?
it. I'm not able to see it correctly. But anyways, you just like read it out so that I can have it.
You need to just scroll down, sir. Anyway, I'm reading it out, sir.
Okay,
He
okay.
says, Professor Sandeep Das says, sir, we have been trying to see the pattern of river Ganga, how it changes
Yes.
its course, new landform, etc. We have used a limited data set. Can you please suggest where we can get data set freely available so that we can follow the pattern month-wise and analyze?
Yes, that is again the
Same
answer is
answer.
similar.
Yes.
Answer is similar that you have to first look for the region, lat and long of the region in which the river is being you can say flowing, and you have to take the complete range, because when you specify the region for the purchase of the satellite data, you have to specify the corner, lat and long of a rectangular area basically, right? So you have to give the corner one opposite corners, right? And you just take the lat and long, you take with the help of Google Earth, you identify the span of the area on the surface of Earth for which you want to take the data. This you have to specify as a specification. Second consideration you have to do is that since you are talking about, you can say, determining the course of a river, change in that. So definitely you have to look for, you have to determine the kind of frequency in which you expect the change to happen. And you have to determine, select that satellite which is having, you can say, the repetitive duration falling into that particular duration, similar conforming to that duration. This is second consideration. Third consideration is you have to look for that which frequency band and which kind of data will help you out, right? Of course, it is from an Earth observation, observing satellite. So you have to look for the literature where the different kind of similar studies have undertaken, and you can determine the kind of frequency. And sensor, of course, I will say to you that you should use a SAR sensor, or maybe some IN-SAR or Fall-in-SAR. Reason being that that is the current trend, and you may choose to have some fusion with optical data just to enhance your results, right? So change analysis, change detection, basically this is known as in the literature, which you can just find it out on Google, right? And I think these considerations will help you out in selecting the data and doing certain, applying certain algorithms just to complete your study.
Thank you, sir. But I will request again, Professor Chirodip, kindly look into the matter, okay, so that we can at least collect few images through which our students and professors can continue the research. Anyway, sir, you can kindly maximize the questions panel if you want to see it, sir. I am reading the next question. Which satellite can get the highest image resolution? That was from Progapun Roy, who is again our student. So which satellite can get the highest image resolution? I don't know whether you can.
Which satellite
Can get the highest image resolution?
See, again, as I've told you, nowadays we have got resolution, highest possible resolution is few centimeter by centimeter pixel. As I've told you, even 30 centimeter by 30 centimeter pixel is available in the form of the data. But true high resolution selection will not serve the purpose. Reason being, because that will simply, you can say, increase your data size. Right? Higher the resolution, more is the data size. And now the trend is that we are trying to have more information in the less data. So this is the
Right.
underlying. So we should look for either the fusion of the low resolution data with some high resolution data, or to two low resolution data just to have a high resolution, right? One field domain is like super, this thing, there is one term, super resolution, I think, no, there is a term called, in image processing domain, there is one term I am not able to recall at present, right? So that is the term like superconductivity. This term is similar to super resolution, I think, right? Where
Yes.
you can
Right.
have more and more resolution from the low resolution data.
Right.
So you have to be very careful in selecting the resolution. Merely having the high resolution will not serve the purpose, right? That will make your
Yes.
overall system very slow.
Yes, so actually image, if you are applying some image processing algorithm on that also, then also having a huge data or a high size data may lead to requirement of a high-end computer also. That is what sir is meaning to say, definitely. So Mr. Prokhar Narayan, he has got a question. Sir, which software are the more, okay, no, so, for the previous question was from Saptoshi Sengupta. He asks, sir, which software do you use for satellite image classification?
This I have told you that I have used NV, which I mentioned during my presentation also.
Yes, sir. But
Environment for visualization of images. And this is
yes,
a commercial software, this is a paid software. But nowadays, for handling SAR data, you have got certain open source software available. And again,
yes,
the trend is towards opting for more and more FOSS, free and open source software in every
right.
domain. People
Yes,
are trying to develop, and people are trying to use reliance on the more and more open source software. Reason being that in that case, that is have got wide accessibility, and people
right.
don't have to spend money, because as academicians we are normally short of money, right? Both as a teachers as well as the students, right? So we have to look
Right.
for funds, and the R&D efforts are supported the way you all know, because we are living in an Indian system, so things are happening very slow. But
Right.
anyways, um, uh, the this thing is that NV is one, then there is Geomatica is another one, right? Then Pulsar is one open. So when you Google it, you will find out a lot of softwares. And for classifiers, again, you have to rely on third party, because you have to take the data to MATLAB environment. There you may be using some neural network or writing your own code. So you have to import and export the data from NV to third party softwares, where you can apply your customized algorithm separately, and bring again, then import the data into the uh, satellite image processing softwares for showing all those results which I had shown to you in the form, because MATLAB is not able to show that kind of results. So you have to resort to some kind of satellite image processing software for the purpose.
Okay, so Chirodip, it's quite Professor Chirodip, it's quite obvious that the MATLAB is not enough. So you are, I'm sure that you are relying, or we are relying a lot on MATLAB. We have got the licensed version of it, but then
Also, I have
you
noted
must
the
look for
software.
some other alternatives. Okay, so
Definitely.
Prokhar Narayan's question now, sir: which classification method is the most important, is the most appropriate for land use, land cover classification?
See, again, this is a very tricky question. As I've told you, this is if we know already that which classifier is best, then there is no need of further research,
Yes, right.
right?
Okay, so
So
right, sir.
we never know which is best. Even for our
Right.
personal use, we don't know what is best, right? We
Yes.
keep on trying different things.
Keep on trying.
So we
Right.
are never sure, because if we reach best, then there is no further directions, right? And in that case, so this is a matter of, again, the particular application, kind of terrain, kind of data, kind of the processing systems, kind of application, that will decide that which classifier is used to be will be the best for the purpose.
Okay, so one question from senior professor Indranil Vasu. He asks, sir, can you please give an idea of the accuracy you expect if you analyze the image data using CNN?
Yes, definitely. For the JPEG image in image processing domain, right, we are getting accuracies as high as something like around 90%, so that they can be used in. But again, there the problem is the system becomes very, very slow.
Right.
So a lot of delays are there. So there the challenge is to reduce the delays. Okay, because
Right.
CNN algorithms, as they are being, you can say, uh, reported in the literature, we have seen that uh, the people, they represent very good architectures, right, of CNN, very complex diagrams in the papers. But these diagrams, they are good for academic research, but these diagrams, they not be very good for practical applications. And we are basically looking for some hardwares, matching hardwares, which can process the data. That's why I told you about high performance computing, right? Because this is
Right.
same kind of thing. CNN is a very, you can say everybody is excited about CNN, but to realize them practically, because we are using workstations and laptops with good number of GBs of RAM, right? And good processing speeds, few gigahertz, and then we get results in few milliseconds, and we say, okay, the things are good, but they're not a practical system. You cannot carry on laptop everywhere with you if you want to use a, like, if somebody asks you that you have to use a mobile with a laptop, right? So laptop you have to hang on your shoulder and mobile in your pocket. You can use your mobile only if you want, if you have your laptop with you. Then I think nobody will like that kind of proposition. So this is the scenario basically. So academically this is good, right? But we can have academically, I have seen some 90% plus even for video processing and image processing accuracies, but that is again on JPEG, right? But on satellite data, again, the question is still tricky, right? And I have not seen as such, and I'm not confirmed, but definitely it has to be 95% plus if it is to be a practical system.
Okay, so Professor Indranil Basu now comments that thank you for your valuable insights. We need a combination of algorithms plus high performance processors. Okay, sir. So thank you. Professor Sandeep Das was wanting to, I don't see any other question in the question panel, but Professor Sandeep Das was willing to ask a question orally. So if Professor Sandeep Das, you can unmute yourself. If you can unmute yourself, yeah.
Yes, thank you, Dr. Vikas. Thank you for the lecture that you have given. It was very insightful. My question is in the continuation with my previous question. Actually, we have taken the data from the Google Earth, and the problem that we face that we are getting result, but the data set was very limited. Is there any other option? That means, can we get any kind of limited data for a certain period from Landsat or anything else which is freely available?
See, if you want to use for the research purpose, then free data that is available on the internet has got very limited scope, as you mentioned.
Yes.
The reason being that they are just for a kind of just as a sample. They show it, they post it on the internet, but that may not be usable for the actual research. If you
Yes.
want to do research, then definitely you have to go for some kind of you can say academic purchase from the agency which has launched the satellite, and that is available online. You can order it online and you will get the data online. So a
Okay.
few GBs of data you will have to have if you want to have some meaningful research.
Okay. Okay. Thank you, sir. Thank you. It was very insightful.
Welcome.
But please look for the academic purchase, Professor Chiradip. The same thing I repeat once more to you.
Yes.
Okay, so thank you, sir. It was really, really a wonderful, insightful lecture. I will request Shohita, our student, to kindly take this over from here if you want to conclude. Yeah.
Thank you.
Thank you, sir.
Thank you.
When we studied satellite communication and digital image processing, then we thought perhaps all these subjects are for researchers. But the way you have demonstrated was amazing. Now, I'm very much sure that our student fraternity can nurture some basic operations on satellite and image processing. Thank you very much, Dr. Mittal, for your excellent presentation. Starting
Okay,
from
thanks.
basic of introduction, you have very nicely demonstrated the types of satellites imagings. After that, you have excellently described the brief of other concepts like feature extractions, pre-processing. Starting with the land cover classification, you have beautifully shown its accuracy of it, and then microwave active sensors. Then you elaborated SAR, pulsar, and pulsar-based feature extraction. You have also provided dominance of scattering. Not only that, but also you have shown us recent trends of research on satellite image processing. Worth mentioning, very few like high performance computing in SAR data processing, new methods, and further improvement of the multipolarization in SAR algorithms. And then you have shown SAR-driven machine learning methods and application for the land use, land change analysis. It was a great learning experience for all of us. In future, I believe our relations will continue further in future collaborations from our side. We will expect you to visit our campus in Jaipur once the situation normalizes. Once again, thank you, everyone.
Okay, thank you. Thanks a lot for having a patient hearing and having a wonderful session of questions. Very good questions were raised, and I think I have been able to clear some of them as per my capabilities. Okay.
Thank you. Thank you, sir.
Okay then. Thank you. Thank you.
Looking forward to meet you soon. Thank you so much.
Definitely. Same here. Okay then.
Thank you.
Bye. Bye.
Thank you. Bye.